Well, let's continue with the second part of the test about Unit 6. If a consumer has the utility function the logarithm of x squared, then the consumer is, well, the consumer will be risk averse. Why? Because we can take this exponent 2 and take it outside the logarithm, and we have 2 logarithm of x, and that is clearly a concave function, okay? Because we should know which the graph of logarithm of x is, okay? So if we don't know, we just differentiate it twice. Here it should say just x, no xy, okay? Then risk averse clearly. Well, Nadal, 12 times Roland Garros winner, is playing in 1 hour new Roland Garros final against a young unknown player. You bet 10 euros on the unknown player's victory, which means that if he wins, you will receive 100 euros, giving a profit then of 90. The match begins, and after 2 sets, surprisingly, Nadal trails 2-0. Remind that in tennis there is no draw, and that Roland Garros is when a player reaches 3 sets, okay? When he wins 3 sets. So, the victory of Nadal at that point is paid 5-1. You decide to bet 20 euros for the Nadal victory when he trails 2-0. Thus, you will gain 70 euros no matter who wins. You are using a bet as an insurance. You would gain more if you didn't make the second bet. Okay, let's see what happens in each bet and in each scenario, okay? Then, the possible profits. If Nadal wins, the first bet, I bet that Nadal loses, okay? So I would lose my 10 euros from the bet. But for the second bet, if I bet 20 euros and my money is multiplied by 5, so I would earn 100 minus these 20 euros, so profit of 80. So at the end, 70 euros if Nadal wins 3-2, yeah, because he's losing 2-0. Then, what about if Nadal loses, if the outsider wins? From the first bet, I would win 90 euros, and from the second bet, I would lose my 20 euros. So, at the end, I would win 70 euros, okay? I explained you this in class because I think it's a very beautiful, well, like conclusion, or we can take from this Unit 6 to use in our lives, to use in investment, and so on. So you will win 70 euros no matter who wins. That's correct. But be careful, because D says that both A and B are true. So you are using a bet as an insurance. Yes, because when I make this second bet, I am ensuring a winning of 70. I could gain more if I didn't make the second bet. Maybe I could, but you would. No, I wouldn't. Okay, it's not for sure. If Nadal wins, I lose 10 euros if I don't make the second bet. Okay, so the answer for this beautiful exercise is D. Now, number 14. An insurance that pays 1000 euros if the bad state of nature happens, which will happen with a probability of 5%, so 0.05, is a fair insurance if the total premium we have to pay to the insurance company is, okay, if the insurance is fair, I will have to pay a per euro premium identical to the probability of the bad scenario. So I should pay 0.05 euros for each euro. Okay, in short, so 0.05 times 1000, okay, 0.05 times 1000 is 50 euros, okay? Then, these are the names of the parameters we use in class, okay? And the calculations would be as easy as this, okay? This is a very easy question that I think that it's important to have it clear. So 15. Fernando has a car which current market value is $30,000. He loves riding fast. Hence, we could consider him as a risk, well, lover, yeah, lover. And his utility function could be given by, well, it could be A, B, and C, but we can see that the utility function on A is concave, the utility function on B is also concave, and the utility function on C is x squared, that is convex. So as a risk lover, as a risk lover's utility function must be convex. The correct answer is C. Okay, you have here another easy and good exercise. Then 16. Gabriel has already bet $5 that Trump will win the next US president election. He thinks that the probability of success is 0.60, and if Trump wins, he will be given $9 back, so $4 profit. What's his expected profit? Be careful. Expected profit, okay? In fact, this is an exercise from probability. Sorry, this is not an exercise of microeconomics. Why? Because we what we want to maximize in this unit is not the expected profit, it's the expected utility. Okay, that I wanted to remind that, and just in case to calculate the expected profit. Okay, so Gabriel will win 4 with a probability of 0.6 and will lose the $5 he bet with a probability of 0.4. So his expected profit nowadays is 0.4. Okay, so a very easy question. It's A, the answer. Okay, now Clara is the owner of a small grocery in a dangerous suburb in Baltimore. Clara is lovely and her clients appreciate her as much as the small criminals in the neighborhood do. Anyway, she's tired of this situation and she decides to sell the grocery. Okay? So she decides to sell it. Okay? She will do it tomorrow morning. But she knows that even in such short period of time, just one night, thieves may appear and the selling price of her grocery would drop from $30,000 to $10,000. She considers that the probability of occurring the robbery is 0.05. So she calls Andrea, her insurance manager, who offers her an insurance valid for tonight, with a premium of 0.10 per each dollar insured. Would you consider fair insurance the insurance Andrea is offering? Well, the gamma, the per unit premium of the insurance is 0.10, and the probability of the bad state of nature occurring is 0.05. So it's not a fair insurance, okay, because gamma is not equal to PB, yeah, to the probability of the bad scenario. We even could consider that this is a expensive, okay, an expensive insurance. Perfect. This is a very good exercise that I made for you, because you know that all the exercise you have are risk averse with fair insurances. Okay, so let's see. It's very interesting to see what happens here to Clara all over these following questions. Okay, so try to remind what is happening here. Yeah, the story. Okay, so Clara is going to sell for sure the grocery tomorrow. Yeah, okay, perfect. Now 18. Which are Clara's consumption contingents if the robbery happens? B. Bad state of nature, and if not, good state of nature as functions of the total insured K. Okay. The contingent consumption if the good state of nature happens is she will receive $30,000 from the buyer, okay, and he pays the insurance, that is 0.10 times the quantity insured. Now, if the bad state of nature occurs, she will receive tomorrow $10,000 from the buyer. She has already paid the insurance, okay, if she buys, of course, and she receives K from the insurance because of the robbery, yeah, because of the bad state of nature happens. Sorry. If we operate here, we have 10,000 plus 0.9 K. So if I think we have it here, yeah? This is the correct one. 10,000 plus 0.9 K. If bad state of nature happens, this will be her money. If the bad state of nature happens, if the robbery happens, and this will be her money if the good state of nature happens, if there is no robbery. Now, we will use these expressions in the following questions, okay? What is the budget constraint of Clara? Okay. You have here two ways, okay? You have like a trick that I don't like it very much, which I don't like very much, sorry. And we have the opportunity to solve this system of equation here, just to equalize K's, okay? So from the previous exercise, from the 18th exercise, we had this. If we isolate here K, we find this. If we isolate here K, we have this, okay? So we equalize them, and we have 30,000 minus CG divided by 0.1 equal to CB minus 10,000 divided by 0.9. Perfect. Then operating, we have this equal to this, and now 27,000 minus 0.9 CG equal to 0.1 CB minus 1,000. Then we carry the variables to the left hand side, and we have 0.1 times CB plus 0.9 times CG equal to 28,000. Okay, so this is the budget constraint. Then the first one, but be careful, because the option D, it says both A and B are correct. Maybe you may think that as we found the straight line, yeah, the constraint, that's the one, and it can be another straight line, and of course it can't be another straight line, but that straight line can be written maybe in many forms, in many ways. And if I multiply here by 10, I have CB plus 9CG equal to 280,000. Okay, so be careful, because these two expressions, I tell you many times in class, represent the same line. So both are valid to use as the budget constraint for Clara. Now, 20th. Considering Clara's utility function is logarithm of x elevated to 10, so 10 times logarithm of x, as we saw before in the second or third question, I don't remember, which are her optimal contingent consumptions. So now we introduce the utility function of Clara, so we can find her optimal consumptions. Okay. Now the problem Clara faces is to maximize this utility of a lottery, or this expected utility. Okay, is 0.05, the probability of the bad scenario, times CB elevated to 10 plus the logarithm of course 0.95 times the logarithm of CG elevated to 10. Then subject to 0.1 CB plus 0.9 CG equal to 28,000. So we rewrite the utility function carrying these exponents to the before the logarithm. So we have 0.5 times logarithm of CB plus 9.5, because it's this times 10, yeah, logarithm CG. Now the optimality condition, if it exists, is the MRS of this utility function, yeah, equal to gamma divided by 1 minus gamma, as we know from theory. So we differentiate this utility with respect to CB. We have 0.5 times 1 divided by CB, and here 9.5 times 1 divided by CG, okay, equal to gamma divided by 1 minus gamma, that is 0.9. Well, if we operate here, we find this, that it is very interesting. Okay, it's very interesting. I always try to read this to you in class. Okay, always in every exercise I'm trying to read this to you. Then what does this mean? That Clara will buy the insurance such that if the good state of nature happens, he will have a wealth that is more or less twice the wealth of the consumption if the bad state of nature happens. Okay, so this is quite different from what we get in all the exercises in class. Remember that I've told you many times. Okay, so we substitute it at the budget constraint, yeah, here, and we have 0.1 CB plus 0.9 times CG, and substituting is this, equal to 28,000. So if we isolate CB, we get this, and with the calculator we find that it's $14,000, and CG is 2.11 times that, so $29,555.55. That is answer A. Okay, sorry, A here. Perfect. Now still with Clara. Finally, how much insurance should Clara buy? Is she buying a full insurance? Okay, well, we have to continue with the exercise. Okay, then we go to these equations where we had isolated K, yeah, in exercise number 19, and for example from this one we substitute CG and we get so $4,444.44. So this is the quantity she will insure. Okay, well, she will not buy a full insurance because the maximum loss, remind, it was, I mean, 20,000, I think it was 20,000. Of course, it was more than $4,000. So she's not buying a full insurance. It's quite logical because even if Clara is risk averse, she finds an expensive insurance, yeah? So she buys insurance, but not so much, yeah? Perfect. Now, consider Clara from the previous exercises. Suppose Raul finds out that she's going to sell the grocery the next day, that Clara is going to sell the grocery, yeah? And he offers her $28,400 for the grocery before Clara calls her insurance manager. Be careful, before Clara calls her insurance manager. So we need to forget about the insurance, yeah? Will she accept the money from Raul? Okay, well, maybe we should find the certainty equivalent and compare this quantity with the certainty equivalent that we know is the money Clara has in mind if she wants to sell the grocery before anything happens. Okay, so we calculate the certainty equivalent. The expected utility is this one. Okay, the utility function was this one, 10 times logarithm of x. This was the probability of the bad scenario. These were the contingent consumptions. So the expected utility is 0.05 times this plus 0.95 times this, and it's equal to 102.54. Then we calculate the certainty equivalent. The utility of that certain money, then 10 times the logarithm of CE, equal to this expected utility we just have calculated. So we isolate CE taking exponentials, yeah, and we find that CE is $28,000, 395.90. Okay, then as the certainty equivalent is well, this is not okay. This is not okay. I should compare with this money. Okay, sorry, with this money. So I will explain then better. Forget about this number. Here it should say 28,400. Okay, then Clara, the minimum money she will accept for the grocery is this one. As Raul offers her a little bit more, just $4 more, she will accept the money from Raul. Okay, I just forgot here 4. So here you have number A, yeah, or letter A. It would be the answer. You have a good exercise. And suppose instead Raul's 28,400 offer is too late and Clara has already bought the insurance in question 17. Okay, now Clara has the insurance bought. Will she accept the money from Raul? Okay, we should find the expected utility after the insurance is being bought. Then these were the data, and the expected utility is 0.05 times the utility if the bad scenario happens, and the utility with the bad scenario but with the insurance was $14,000. Okay, and with the good scenario it was 29,000 blah 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 dollars. Okay, so if we calculate this, we have 102.57. Then we calculate the certainty equivalent with the same steps. Okay, the utility of that certain money equal to that expected utility level we found, and by isolating CE we find that the number is $28,471.60. So as again here I have the mistake. The comparison we have to do is with 28,400. Okay, so she will not accept the money from Raul because Raul is offering her 28,400, and the minimum money Clara should accept is this one. Okay, so the answer should be this. Okay, well, here you have these 23 questions